Hello everyone, we have been continuing with the full course on circles, and now in this video we are coming to the properties or theorems based on congruent circles. We have already learned in the previous videos regarding the congruent circles. What are congruent circles? Any two circles whose radii are equal are congruent circles, or sometimes we call them equal circles. Here the first property of that is equal chords in congruent circles are equidistant from the centers. The same property we learnt in one circle also, that the equal chords are equidistant from the center of the circle. Now we will go with the same type of theorem in congruent circles. Here we have two congruent circles. The center of them are O and O dash respectively, and the radii of each is R. We have been given that these two chords AB and CD in both are equal. We have to prove that the distance of these from their centers are equal. So we have to prove that OE and O dash F are equal. OE is perpendicular to AB and O dash F is perpendicular to CD. And we have already learnt about the elements of the theorem. First we draw the diagrams as we have discussed just now. What is given? Two congruent circles. Two congruent circles. COR and CO-R, in which chords AB is equal to CD. OE is perpendicular to AB and O dash F is perpendicular to CD. What is to be proved? To prove OE is equal to O dash F. Construction. We need a construction in this, that is join OA and O dash C. We write here the construction. That is join OA and O dash C. Now comes the proof. We know that if we draw a perpendicular from the center to a chord, that bisects the chord. So we'll write, since OE is perpendicular to AB and O dash F is perpendicular to CD, this implies that AE is equal to BE is equal to half of AB. Similarly, CF is equal to DF is equal to half of CD. And we are given that AB is equal to CD. It means half of AB is also equal to half of CD. This implies that AE is equal to CF. And now we can take these two triangles. In triangle OEA and triangle O dash FC, what we find? We are having OA is equal to O dash C because both are the radius of the congruent circles. They are equal to R. Then we have angle OEA is equal to angle O dash FC, that is each is 90 degree because OE and O dash are perpendiculars. And now we have AE is equal to CF, that we have already proved. So we are finding in these two triangles, these angles are 90 degree, means they are right angle triangles. These are the hypotenuse of them and one of the sides are equal. So by RHS they are congruent. Therefore triangle OEA is congruent to triangle O-FC by RHS congruence. And if they are congruent, then we can say that OE is equal to O-F by CP/CT, that is by corresponding parts of congruent triangles. So not only in the same circle, even in the congruent circles, equal chords are equidistant from their centers. The converse of the theorem is that the chords in the congruent circles which are equidistant from the center are equal in length. And to prove that, we draw the diagram here. There are two congruent circles with center O and O dash. The radius of both are R. So we are writing in given congruent circles COR and CO dash R, in which there are two chords given AB and CD, such that OE is equal to O dash F, where OE is perpendicular to AB and O dash F is perpendicular to CD. It means they are equidistant from the centers. To prove, we have to prove that the chords are equal. It means we have to prove AB is equal to CD. Now there is a construction required, that is join OA and O dash C. The proof. We know that the perpendicular drawn from the center to the chord bisects it. So we can write here again, since OE is perpendicular to AB and O dash F is perpendicular to CD, this implies that AE is equal to BE is equal to half of AB, and also CF is equal to DF is equal to half of CD. Now we are coming to these two triangles. In triangles OEA and triangle O-FC, what do we find? OA is equal to O-C, because both are the radii of the congruent circles, they are each equal to R. OE is equal to O-F. This is given to us. And angle OEA is equal to angle O-FC, that is because both are 90 degree, since they are perpendiculars on the chords. So what we find? Right angle triangles, hypotenuse and one of the side. By RHS they are congruent. So we can write, therefore triangle OEA is congruent to triangle O-FC by what? By RHS congruence. And if they are congruent, their corresponding parts are to be equal. This implies that AE is equal to CF, that is by CP/CT, corresponding parts of congruent triangles. And we know that AE is half of AB and CF is half of CD. And if half of AB is equal to half of CD, it means AB is equal to CD, and this is what we had to prove, that both the chords are equal. Next property of congruent circles we have, if there are any arcs which are equal in two congruent circles, then their corresponding chords are equal. So we are drawing the diagram. There are two congruent circles with center O and O dash and the radius R. There are two arcs AB and CD which are equal. We have to prove that their corresponding chords AB and CD are also equal. So given congruent circles COR and CO dash R, in which arc AB is equal to arc CD. To prove chords AB and CD are equal, AB is equal to CD. What is the construction? There is some construction required. We join OA, OB, O-C and O-D. Now comes the proof. We have been given that arc AB is equal to arc CD. And we know if two arcs are equal, their degree measures are equal. It means we can say that degree measure of AB will be equal to degree measure of CD. What is the degree measure of AB? That is angle AOB. Degree measure of CD, that is CO-D. It means these two angles are equal. Suppose each is theta. Now we can take these two triangles. In triangle AOB and triangle CO-D, what we find? OA is equal to O-C and OB is equal to O-D because all are the radius of congruent circles, they are equal to R. And angle AOB is equal to angle CO-D, we have just now proved, because each is theta. Here two sides and the angles bounded by them are equal. Therefore, the triangles are congruent by SAS. So we can write, therefore, triangle AOB is congruent to triangle CO-D by SAS congruence. And if they are congruent, their corresponding parts are equal. It means AB is equal to CD by CPCT, that is corresponding parts of congruent triangles. And that is what we had to prove. So we could prove that if two arcs in congruent circles are equal, their corresponding chords are also equal. The converse of this theorem is that if in two congruent circles chords are equal, then their corresponding arcs are equal. For this we have drawn the diagrams. Two congruent circles with centers O and O' and radius R. In this we have been given two chords AB and CD which are equal to each other, and we have to prove that this arc AB is equal to arc CD. So we write, given congruent circles COR and CO'R in which AB is equal to CD, that is chord AB is equal to chord CD. To prove arc AB is equal to arc CD, and we have a construction, that is join OA, OB, O''C and O''D. Now in the proof we take these two triangles. In triangle OAB and triangle O''CD, we have OA equal to O''C and OB equal to O''D, that is because all are radius of congruent circles. They are R each. And then we have been given that AB is equal to CD. This is given to us. So all the three sides of the triangles are equal. Can we say that they are congruent by SSS congruence? Yes. Therefore, triangle OAB is congruent to triangle O''CD by SSS congruence. And hence their corresponding parts will be equal. So we can say, therefore, angle AOB is equal to angle CO''D. Do we find that this is the measure of arc AB and this is the measure of arc CD? So this implies that the measure, degree measure of arc AB and degree measure of arc CD are equal. What is angle AOB? This is the degree measure of arc AB. CO''D is degree measure of arc CD. It means we are finding degree measure of arc AB is equal to degree measure of arc CD. And if the degree measure of two arcs are equal, then arcs are congruent or equal. It means we can say that arc AB is equal to arc CD, and this is what we have to prove. So we could prove that if two chords in congruent circles are equal, then their corresponding arcs are equal. The next property is, in congruent circles, equal chords subtend equal angles at their centers. For the proof of this, we have drawn two congruent circles with centers O and O dash and the radii R each. Two chords AB and CD in that are equal. We have to prove that angles subtended by them at their centers means angle AOB and angle CO dash D are equal. Given congruent circles COR and CO dash R, in which AB is equal to CD. To prove angle AOB is equal to angle CO dash D. And the construction we have, join OA, OB, O dash C and O dash D. Now comes the proof. In triangle AOB and triangle CO dash D, what we have? OA is equal to O dash C. OB is equal to O dash D. There are each the radii of congruent circles. And AB is equal to CD. This is given to us. It means we find that all the three sides of this triangle are equal to the three sides of this triangle. And hence by SSS congruence they are congruent. So we can write therefore triangle AOB is congruent to triangle CO dash D by SSS congruence. And if they are congruent, corresponding parts are equal, it means we can say that angle AOB is equal to angle CO dash D by CP CT, corresponding parts of congruent triangles, and that is what we had to prove. Hence, proved. So we could prove this theorem also the same way. The converse of this theorem is that the chords which subtend equal angles at the centers in congruent circles are equal. We have drawn the diagram here with congruent circles having centers O and O dash, radius R each. In this there are two chords AB and CD which are subtending equal angles AOB and CO dash D in the circles at their centers. What is given? Congruent circles COR and CO dash R, in which chords AB and CD are such that angle AOB is equal to angle CO dash D. To prove AB is equal to CD, and we have a construction, join OA, OB, O dash C and O dash D. Now we are coming to the proof. For the proof we take these two triangles. In triangle AOB and triangle CO dash D, OA is equal to O dash C, OB is equal to O dash D because all are R, that is radius of congruent circles. And angle AOB is equal to angle CO dash D. This is given to us. So we find two sides and the angles bounded by them are equal. Therefore, the triangles are congruent by SAS congruence. So we write therefore triangle AOB is congruent to triangle CO dash D by SAS congruence. And hence their corresponding parts are to be equal. This implies that AB is equal to CD. It means chords are equal. This is by CPCT, that is corresponding parts of congruent triangles. And this is what we had to prove. Hence proved. So we could prove that the chords in congruent circles which subtend equal angles at their centers are equal in length. After learning about all the properties of congruent circles, in the next video we will learn about the angles subtended by an arc at the center of circle and also in the alternate segments, and see the relation, what relation is there between them, and also we'll learn the proof of them. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.